What other class you have today? Physics double class. Nothing else. What did you know on Monday? That's double period. Yeah. With the double period. And Tuesday. Sign. Who was your maths teacher? Lisa. Yes. Who? Yes. You're Anish. Okay. Anish.
Anush.
What's your name?
Gaurav. Gaurav.
There we go. Welcome to the 10th standard. Official welcome. All of you have successfully passed out of 10th standard, 9th standard, and you come to the 10th. A big achievement, isn't it? So how are you, what are your feelings about coming to the 10th standard? What? Good. What, mixed feelings or what? Mixed feelings. Why is that mixed feelings?
Stress because of boards.
Are you, even before the stress comes in, you're saying stress. Why? I know, everybody is talking about board exam, board exam. Cool. Just as we have done a 9th standard, we are going to do the 10th standard, that's all. Slight differences are there, which I put up on the board so that we understand how we have to tackle it. What's your name?
Robi.
Yeah, Droni. So, you all belong to some class, some same school. This one, which one?
Amity.
Amity. That's all there. What about you?
Right.
Okay. She's the only one from Rand, you want to work from Rand. Now, there's no need for anybody to get scared just because it is a 10th standard exam. Okay? I'll just give you a few basic tips right from the very beginning because this is our first class. So we know how easily we can tackle the whole thing. Okay? First of all, I'd like to tell you something about your timeline. Right now we are in March. Correct? April, May, June. Yes. July, August, September, October, November, December. That marks the end of your 2025 and we begin with our 2026 year. And Jan and Feb. Okay, so that basically gives you how much time? Plenty of time. plenty of time before you actually take up your board sometime in February 2026. So it's the same thing as your ninth standard. There's nothing to be scared of. Okay? But the only difference compared to the ninth and the 10th standard will be that in your 10th standard you will have complete portion. This is a big difference compared to your ninth standard. That means that the entire textbook that you are seeing will be asked. That's the only difference. Okay. Usually in ninth standard, what happens? We do one part of it first semester, that is over. Then we start the second semester, that is the second semester. Okay. And we don't bother about what is it. But here, whatever we are learning now, right? It will have to be carried on till there. Isn't it? So we don't forget whatever we are learning. And that's where what is important is you're going to keep it in your long-term memory. That's also very, very important. Memory is of two types. One is a short-term memory and the other one is long-term memory. Okay, short-term memories. Do you remember which car was there going in front? Do we remember the number of the car? No, we don't know who the person was in the lift. But short-term memory, just for a second, it's just fleeting. Or I don't know what I have read in the newspaper today, I may forget after 2 days. Okay, but long-term memory is very important because we need to make an effort to keep it in the long-term memory, because not only are we going to use it here, but if we are taking up the 11th and the 12th as science, these portions are also going to be very useful. How do we develop this long-term memory? What are the techniques? Okay, so there are certain few techniques that we do. One happens to be what is known as repetition. Okay, so you keep on learning, you keep on learning. That's one very, very important technique how we can improve our long-term memory. Okay, so how do we achieve it? By giving you repeated tests. Okay, so if you look at the timeline, we are starting here in March, April, May. In June, you will have, as soon as the school reopens, you will have a test. Isn't it? Then in July, August again, you will have a test. Again, September, October, you will have your term 1 exam. Isn't it? Then by November, most of the portions are over. December, you will have your mock exam, and then in February, you will have your board exams. Does it make sense? So what happens at each of these time frame? Okay, because we are giving you tests and examinations every alternate month, you keep on reading, you keep on revising, so that whatever you are learning, you are going to keep it in long-term memory. Have you understood? Okay, so that is one very, very important thing. That repeatedly you are going to read, and that is how you can improve and keep it in your long-term memory. Not only for science, it's going to be for maths or Hindi or Marathi or whatever it is. Here, second thing is how can we improve this is by doing your homework assignment. It's very important. We are not giving you homework only because we want to bore you, we want to trouble you. No. Does it mean that if I give you homework, do I want to trouble you? Why do we do that? Because whatever you're learning in classwork, that has to be more reinforced. Samjha na? When you're putting the bricks, they're putting cement, right? Every day they have to keep on watering so that that cement becomes very hard. Yeah? The same way, that whatever I'm teaching in the class, if you're very attentive, about 85% of it you will be able to absorb. If you're very attentive. Sometimes children are sitting in the class, but the mind is wandering somewhere else. Not that way. Understood what I'm saying? Paying attention, 85%. What happens to the 15%? That is where this is going to take effect. So by doing the homework, you're trying to remember what teacher has taught you in the class, and therefore it is getting reinforced. Have you understood? Okay. So these two things are going to be very important. Taking tests repeatedly and reading. Second thing is doing your homework regularly. Even if I don't give you a homework or if the teachers don't give you a homework, it becomes important for you to go and see, आज teacher ने क्या सिखाया? Okay, what have we done? If it is not possible today, Saturday, Sunday is always there. Okay, but you should come prepared for the class whenever we have a class. Is that okay? So that is another very effective method of reinforcing whatever we have been learning. Third most important technique is your time management. What does it mean? What does it mean to you, time management?
To set up a proper timetable.
Okay? Timetable is one thing. Time management. Do you study just 1 week before the exams? Please avoid that. If you people are in a habit of, अरे जून में एग्जाम है, अभी चलो वीक देखेंगे, so अप्रैल छुट्टी है, मई छुट्टी है, let's enjoy, and then we will read only 1 day before the exam. Does it help? Definitely not. Definitely not. Okay, because usually what happens is once the schools start, all the subjects will start together. Right now we are just about starting with science and maths. Okay, but by the time the school starts somewhere here June, July, all the subjects, everything will start together, and by the time you come to August, and if you're not very thorough with it, then you will feel suffocated. We want to avoid it. Okay, so there's no stress involved if you are using these few particular techniques. Will you remember that? Okay, and please use only one notebook for your work. What am I going to teach? I'm going to be teaching your physics portion of 10th standard. Correct? So all of you are having that notebook. Don't scribble anything else in that. Don't write Marathi or anything else. I brought this book, nothing of that sort. Because whatever I teach you in the class is going to remain in the book. Okay? And you are going to use it for all these examinations. It will be like a guide for you. You understand? So when I'm teaching you, I'm going to give you different type of questions which have been asked in the board examinations. Okay, so that way you will be able to learn more. By the way, some of you are newcomers. My name is Sudha ma'am. Okay, I've had more than 33 years of experience of teaching, right? And I'm from IIT. Okay, so rest assured that all of you are going to be very, okay, you're in good hands here. Any doubt you have, we also have our DS sessions, doubt solving sessions. So there's absolutely no problem as far as learning is concerned. The only thing is you people have to make an effort. Any questions? Any questions? Would you like to jot down a few things from here? What is your takeaway? What are the points that you must remember? What is it? Come on, rattle off.
Repetition.
Repetition, then long-term memory. What?
Time management.
Yeah, read regularly. Yes, do your homeworks regularly. Will you remember that, or you need to jot it down somewhere? You'll remember, all of you will remember? Fine, very good. Okay. What does physics mean to you? Why do we have to learn physics? I don't like physics, I'm not going to learn. क्या सीखा? What did you say? By the way, did you see Sunita Williams back on her? You remember last year we were discussing about it and we were tracking it down. Poor lady went for 9 days and it was extended to 9 months. Yeah. And I was so happy for all of them that they went back again. But an amazing feat. What did we learn? Coming back to my question. What happened? What are the things that we need to learn? Why do we learn in physics? Okay? We are making our life very comfortable here. Just imagine we are sitting in an AC room with lights. Yeah? How is it coming? How is the AC on? Current electricity. Okay? If somebody had not discovered current electricity, we'll be all sitting in darkness or probably in sweltering heat right now. Correct? So, somebody, thank goodness, like Ampere and Faraday, they have worked on it way back in 1800, 1900, and because of the developments and because of the discovery, we are sitting in the comfort. Isn't it? Communication has become so easy. Satellite communication, we wouldn't have thought of it about 100 years ago. All this is possible only because of the various discoveries that we are making. So physics is we are involved in physics in our day-to-day activities. It's not as a separate chapter which is there in the textbook. Every action that we do now, everything that we use now is nothing but physics. Did you see that? Okay. So basically what are we going to do? There are only 4 chapters if you look in your textbook. What are the 4 chapters? First one is, yes, light. Okay, so we are going to be talking about reflection and refraction of light. Second thing about the human eye, where we are talking about how the human eye is so wonderful that you can actually see beautiful things. Next chapter we are talking about electricity, current electricity. And the 4th chapter that we are going to talk about is the magnetic effects. So these are the 4 chapters that we are going to be covering under physics. Okay, so the 4 chapters of course will be covered by the physics, biology and the chemistry. So the first topic that we have, anybody's school has already started the 10th standard? No, you're all having a break now after the exams. Okay, so when does your school start?
School started, but not, they are not yet.
When school started, actually, we are having a camp. So all the practices are going, so no one is teaching.
Okay, right now it's a small break. Okay, fine. You know, and teachers also require time to correct the papers and to declare the result and all that. Okay, fine. So, we are going to be talking the first topic that we are going to be talking about is light. Okay, Kashita, what do you mean by light? Some of them are old comers, so I know their names. Some of you are new here. Kashita, tell me, what is light?
Something from which you get reflection.
I'm not even thinking of the scientific word. What is light? That's all. In simple words, even if it is the 4th standard, 5th standard level, also fine. Then this is light, okay, fine. It is energy, very good. Light is nothing but a form of energy. What else? Anything. What does it do? Don't look into your textbook. Nothing is there in the textbook. Sometimes I'm asking very funny questions. Okay? Puro.
Provides us with vision.
Very good. If there's no light, we cannot see. Just imagine if we switch off and everything and the room is absolutely dark, does the furniture disappear? It's still there, but we can't see. Why? Because of light, yes. Because light helps us to see. It's a form of energy. Okay? And we know the natural sources of light. Sunlight is a natural product. Okay? Right? Then what else? Natural one. What? Stars. Sometimes even fireflies. And then of course we have got so many artificial, like candle and torch and stuff like that. So even if there's a small bit of light coming into the room, it will help we will be able to see. Yes, we will be able to see. What makes it see? How does it see? Of course our eyes are ones which is helping us to see. But what is actually happening to light? For example, light is coming from there. What is happening? Why is it that we are able to see the baby?
Reflecting from the object.
Reflecting. So we are coming to the words now. Okay. When we say it is getting reflecting, what does it mean? That the light is coming. Okay. Yes. It is striking something. Maybe it is a furniture on the floor, and it is getting bouncing back. So that is nothing but reflection. And it doesn't stop there. It hits some other surface. Again, it gets reflected. So that's it. Like just as you have that ball, rubber ball, bouncy ball, you strike it once, it goes, goes in all directions. So that's exactly what is happening to light. It's getting reflected off surfaces. So in the 9th standard, obviously, we have learned about the best reflecting surface. What is it going to be?
Smooth.
Yes, a smooth surface like what? Mirror, yes. So whenever we talk about a mirror, then we know that it is having a very good reflecting surface. What is a mirror made of?
Glass.
It's a piece of glass, correct? Suppose this is a very fine, thin piece of glass, right? One side is the reflecting surface. That means light is falling here and it is coming back. So if this is the incident ray, this becomes the reflected ray. On the back side, what do you find? You find that the surface is silvered, isn't it? So basically, whenever you talk about a mirror, mirror is nothing but a flat piece of glass. Okay, one side of it is silvered, the other side becomes the reflecting surface. Are you clear about these terms that we are using? Okay. Now, since you have already done mirrors, let me see. This is your glass, and this is your mirror, which I am writing it as M and M dash, right? And this is your normal. Okay, so I'll put it as O and N, which tells you a normal. What is a normal? Normal? That is correct. All of you know the answer. Bolo. All of your sign? No, he has not. He has right. Right? First one. What's your name? Right. So, what was I asking you? What's a normal? Is this a normal? Oil is a normal or no? Yeah, why is it called a normal?
Yes.
It's 90 degrees.
Correct. You're right. Correct. You're perfectly alright. Any line that makes a 90-degree angle is a normal to that surface. Correct? For example, is this a normal?
Yes.
Yes, because the pen is perpendicular to the surface of the table. But is this normal? No. So normal, we know what it is, right? Now we are talking about, let us say, a light which is incident onto the mirror. What will happen?
This part.
What angle is this and what angle is this? Now let us say I am talking about I. What is ION and ION? Which is the angle of incidence?
ON.
I go.
ION, or is it ION? Which is the angle of incidence? All of you agree? Correct. So how do we define what is the angle of incidence? Now you know it. I put it up on the board. Now you define the angle formed between
The surface and the normal.
Between?
The normal surface and the
where surface?
mirror.
Angle I is the angle formed between the incident ray and the normal. ठीक है ना? Okay, so how do we define it? Angle of incidence is the angle formed between the incident ray and the normal. Okay? Now let us say this is 40 degrees. What is MOI? What will be that angle? Obviously, 90 minutes. Everybody knows. Now, why I'm telling this is sometimes in the question papers they may trick you. They may give you this angle. So don't take that angle as angle of incidence. Sanjay? Okay. Now everybody knows about this. What ray is that? It is the refracted ray. Okay. Now which angle will this be? It will be obviously angle of reflection. So this is also going to be. So what is the first law of reflection? What is
Incidence is equal to angle.
very good. Angle of incidence is equal to angle of reflection. What does the second law tell us? You know what is the second law? Think about it. We have three things here. Incident ray, the reflected ray, and the normal. They're all in the same plane. They're all in the same. Come on, pick it up. First chapter. Put the date. Chapter number 9. The first thing is laws of reflection. First point. The angle of incidence the angle of reflection. Angle of reflection. Second point is there in your book. Did you see this page? Second point, the incident ray, the reflected ray, and the normal to the mirror, and the normal to the mirror at the point of incidence all lie in the same plane. What does the plane mean? Plane, this is the plane. Yeah, this is the place. Here, this is the plane. Okay.
At the point of incidence
Or on the same plane. At the point of incidence are on the same plane. All lie in the same plane. Put a tick mark in your textbook. All of you will use a pencil to use markings in the textbook only with pencil, not with pen. Okay? Put a tick mark then. Tick, tick. You have your textbook?
No, I did not get it.
Okay, fine. But afterwards you can do that. Okay? Finished? Now, whenever we talk about any type of mirrors, these rules will always be obeyed. You remember that, okay? Whether I talk about a concave mirror or a convex mirror, these rules will always hold good. Okay? So right now we have spoken about a plane mirror. Now let us also see what happens if you are having a curved surface. Right? And if the curved surface is also polished, will light reflect from it? Yes, definitely. Okay, so let's draw a curved surface. Let's say this is a sphere. Correct? So if this is a sphere, obviously this will be the center of the sphere. Right? And I can say a part of it I have cut out. So this part of it becomes a spherical mirror. Why is it called as a spherical mirror? Because it is a part of a sphere. If you see the origin how it comes, okay? So this becomes a spherical mirror. Now this part, if at all the shading or the silvering is from the back side, which part becomes the reflecting surface? It is this side. Okay? So the concave mirror will always look like this. So this is your concave mirror. Okay? What happens in a concave surface? This part of it is silvered. So when light falls on this side, that is on the curved surface, it is going to reflect. Okay? Now the same sphere, suppose I am cutting out only this part. Okay? But this part of it, let us say X and Y, we have shown the silvering from the inside part of the sphere. So I'll just draw this part. This is your X and Y. Okay? And the silvering is taken from the inside. What type of a mirror will that be?
Convex.
It is a convex mirror. So this is your convex mirror. What happens? Because when light is falling on this, it is reflecting. Correct? How will you remember concave and convex? Concave, cave ke jaise. It is like a cave. Convex is the same. So depending upon which side of it is silvered, you can use that as a, okay, it becomes a spherical mirror. Is that okay? Right. Look at the next paragraph. Here. Okay, I think we are on page 135. Am I right? Yeah. These laws of reflection are applicable to all types of reflecting surfaces, including spherical surfaces. Right? Okay. We are forming what are the properties, etc., etc. Now we are talking about different type of properties in a plane mirror. First, we'll see that. Okay. Then, have you all followed this? Now, this was one of the board questions. One of the questions which was asked in one of the board papers. Simple thing. Okay. They will just mark A, B, and X, Y. They'll ask you what is A, B mirror, what is X, Y, and why is it so. So, the type of questions that we are going to be asking is conceptualized. So, if you have understood the concepts, you will be able to answer them. Are you clear about how and what type of questions? So, during my lectures, constantly, I'll also be giving you hints as to what are the type of questions that you will be asked. Okay, clear? Okay. Want to take it down? Because this is one of the questions which is asked. Freehand diagram. You can make your own diagram with a pencil or pen. What type of mirror is AB? What type of mirror is XY? Quickly. You don't want to waste much time on diagrams now. No need to write this. No need to write this also. Just identify that this is what mirror and this is what mirror. That's all. Okay? Coming back to the plane mirror once again. Okay, we are still in plane mirrors. Now all of you will be standing in front of the mirrors. All of us are very familiar with the plane mirror. I want you to think of what are the characteristic features of a plane mirror. What happens in a mirror? You look at your image.
Yes.
So I want you to tell you. They're flipping. So what is that called? What is that called? Your left is looking like a right. We are talking about flipping. What is the word that I'm looking for? It's not an inverted. Inverted as in jayega. So we don't call it as inverted. Left is looking like right. What is it called? Lateral inversion. Samjha? Okay, so that is your lateral inversion. So that's one thing. What else? What happens to the size? Is it the same size as that of the object? Same, no? If I keep the pen in front of the mirror, the image is also the same size. So the size of the image is the same size as that of the object. एक तो हो गया size, एक हो गया about lateral inversion. What else? Distances.
The farther we go, the smaller.
Yes. So the distance of the object. Look at my wording. What I'm saying. The distance of the object in front of the mirror is the same as the distance of the image behind the mirror. It's always going behind the mirror. Correct? So, if you are taking this object further and further, what will happen to the image here? That will also go further and further. Okay? Okay, so the size, distance, and lateral image. One thing. What type of an image is it? You said it already. It's a virtual image. That means it cannot be part of the screen. So what are the characteristic features of the image formed in a plane mirror? Take it up. Characteristics of the image formed in a plane mirror. First point regarding size. Size of the image is the same as or it is similar to that of the object or it is equal to that of the object. The size of the image is the same as that of the object. Size of the object. Next, about distances. Second point about distance. How will you phrase it? The distance of the image is the same as the distance of the object in front of it. Come on. The distance of the image behind the mirror is the same as the distance of the object in front of it. Tell me the third point. Yes, image is laterally inverted. Laterally inverted, or you can also say lateral inversion. That's what the first one. Last point, anybody remembers? One more point. Virtue. Will it be inverted? Will it be inverted? No. Suppose a person is standing like this in front of the mirror. It's always going to be an erect. So the image is always virtual and erect. Sure.
It is erected in concave mirror.
I'm talking now only about plane mirrors. We are talking about plane mirrors. I have not yet started off with the spherical mirrors. Okay? All of you please make a note that we are still talking about a plane mirror. Done? So now we will be talking about concave and convex mirrors. So now we know that mirrors are actually of the three types. I'm not bothered about the plane mirror. Spherical mirrors, if I'm talking about the spherical mirrors, they are of two types, concave and convex. This we already know. Okay. But there are certain terms which are common to both convex and concave mirror because both of them are part of a sphere. Okay. So let's see what are the various terms that we are going to be talking about. Right? This, of course, let me say, I have taken this part. So I'll just show you here once again. So this is the shaded part. Another thing, children, whenever you're asked for drawing, don't forget to put this shaded line. Okay, if you just draw a line and leave it, it doesn't show that it is a mirror. We have children drawing a perfect diagram, but they don't draw this 0 marks. Yeah, so just remember them. These are tips and hints that I'm giving you right throughout. You should remember. Okay. Now, basically what happens here? The center of this surface is basically what's known as a pole, right? So we talk about P, which is the pole. This is your center of the mirror. Okay? So center of the sphere of which this makes a part is the center of curvature. Okay? Now this is usually given by the alphabet C, center of curvature. If we draw a straight line starting from C to P, okay, from C, let us say this is C to P.
Is the normal.
So yeah, so that's known as the principal axis. What is it called? It is a principal axis. Can you just imagine that this is the mirror and this is the normal? Can you imagine, just as we had in a plane mirror, this part, not the entire thing, just this part is a small line there, a small line there. So that part of it is acting as a plane mirror, And this line here obviously is acting as a norm. Okay, so this line is nothing but the radius. Can you understand that this is the radius? It is the radius of the sphere. So this is also the radius of the sphere. Correct? Is that okay for you? Understood? What are the concepts that we are using? So this is your R. So what all have you learned? If you are talking about X and Y, this is your X and Y of a concave mirror. We talk about the pole, the center of curvature. And this of course happens to be a R. Okay. Now if you look at the next page, the very first paragraph talks about focal length, okay, and all the terms which are given in the very first paragraph, right? So before we even come to the focus or the focal length, I have not mentioned anything here. But let's look at what are the things that can happen. Now in this concave mirror, let us say that this happens to be your principal axis. And because I'm saying it is a mirror, obviously I have to show the shading. What do you think will happen to the light if it is falling on the surface here? Let's say there is a beam parallel to the principal axis and let's say this is C and this is B. It's going to get reflected. Okay? Isn't it? Is it going to get reflected or not? Yes, obviously. So it's going to get reflected, it is going to get reflected and passing through this. So this is your incident ray, this is your reflected ray. Right? Suppose I take up another ray. Once again it is parallel to the principal axis. It strikes the surface of the mirror. Once again the reflected ray passes through this part, through this point. And this point is what is known as F, which is the focus. Okay, focus. Have you followed? Okay. So what did you make out? This is your focal length. It is the distance between the focus and the pole of the mirror. That is your focal length. Did you also find what is the relationship between the radius and the focal length? Yes, it's nothing but half. Did you see that? Your focal length, capital F is focus, children. But if जो यहाँ distance है ना, this is I'm writing it as small f. So this is your focal length is equal to half of your radius. Half of this is your f or the focus. Are we good? Clear? I'm reading out the first paragraph on this page. Okay. The reflecting surface of a spherical mirror forms a part of a sphere. Can that be asked as a question? Did you notice every sentence is a question? What is the question there? What is a spherical mirror? So that's your answer. Did you get it? A spherical mirror is a part of a sphere. Right? This sphere has a center. This point is called as the center of curvature of the spherical mirror. I want you to underline the term center of curvature. What is C? Or define. Did you get it? Okay. Now is the center of curvature a part of the mirror? No, it's there somewhere in front of it. It is in front of the reflecting surface. It is a part of the sphere, but it is not as part of the spherical mirror. Okay. So please note that the center of curvature is not a part of the mirror. It lies outside its reflecting surface. Okay. The center of the curvature of concave mirror obviously is lying in front of it. Did you notice this? Did you notice? The C is lying in front of the concave mirror. Did you get that sentence? Okay. However, it lies behind in the case of a convex mirror. I have not yet spoken about the convex mirror. You may note this. The radius, next line. Did you notice that? Did you underline those words? The radius of the sphere of which the reflecting surface of a spherical mirror becomes a part is called the radius of curvature of the mirror. So that's another definition. Which is the radius here? The radius of the sphere, listen to the words that I'm saying. The radius of the sphere of which the sphere or the concave mirror or whatever spherical mirror is a part is called as the radius of curvature. Got it? Please underline the word because I want you to be writing all the definitions. Then it is given by the letter R. Okay. The distance P and C. What is P? Pole. C, center of curvature, is equal to the radius of curvature, even that we have seen. Imagine a straight line which is passing through pole and the center of curvature. This is called as principal axis. Underline the word principal axis. So here which line is principal axis? This is the line. Okay, it's an imaginary line. You can also take it further like that. This is an imaginary line. Imaginary line which is running through P and C is your principal axis. Now this is axis is normal to the mirror at its pole. Is that the correct point? At pole, this is the normal. Is that okay? Okay. Fine till now? Okay. All this will be your homework. To write down all the terms so that you are familiar. Okay. Now there's an activity here. How many of you have played around with concave mirrors? Maybe you must have seen. It's a reflecting surface. Have you seen the concave surface? Oh, yes, very good. Compound microscope basically has one. That's a reflecting surface. Even if you have a new spoon at home, if you have a spoon, nice reflecting surface, as I had much. So what happens? This becomes what surface? Concave surface. What happens to this one? So you can see that. You can actually go home, take one nice shining mirror and then you can play around with it and see what type of images are formed. What happens if you take the spoon away from you? What happens if you get the spoon closer to you? And so on and so forth. Okay. Now, so far we have spoken about what is this? It is your concave. Okay. Now let me show you what happens to convex. This is your convex. Correct? This is your mirror because I'm shading it from inside. Where is the C going to be? Is it going to be here or is it going to be here? On the left side, C is going to be here.
No, it's going to be
On the
because it is
inside.
What is C?
center of
So yeah, if I have to complete the sphere, so it is going to be here or here?
Right.
C is going to be inside. Okay, so this is the C. So did you see the difference? Here in a concave mirror, center of curvature is in front of the mirror. Here it is behind the mirror. This is going to be the pole. As the middle point, this is going to be the pole. This is going to be your imaginary line, which is your principal axis. If you are having a ray of light incident on it, what will happen? It will come back. The same way it will come back. Will it come through the focus? No. It is a bulging mirror. So it is going to spread out, diverging. Okay, so this will go away. Similarly, if I am having another ray of light which is incident, this light will also go away. Converging is coming closer. Diverging is moving away. So this will also move away. Correct? So there's no way. So, but if you are going to draw or extend this behind, it meets somewhere here. What will be that? That is your focus. Correct? Here also we find that is focus. We find the focal and length will be half of your radius. That is also correct. Okay. But did you see? Focus is behind the convex mirror. There it is in front. See the two diagrams. I have drawn only two rays so that it becomes easier. In the textbook, they have drawn many rays. Concave and convex. Okay, clear? Here obviously it is in front, there it is. Look at the last paragraph. Okay, talking about the last paragraph. Right? Observe 9.2. Ananya, a number of rays.
A number of rays parallel to the principal
Is
axis.
everybody okay with the last paragraph that we are reading? Read.
A number of rays parallel to the principal axis are falling on a concave mirror. Observe the reflected rays. They are all meeting, intersecting at a point on the principal axis of the mirror. This point is called the principal focus of the concave mirror. Similarly,
1
observe.
minute. Underline that. Define or what is the focus of the concave mirror. So what will you write? When many rays parallel to the principal axis are falling on a concave mirror, they meet at a point which is called as a focus. Okay. Next.
Similarly, observe figure 9.2. How are the rays parallel to the principal axis reflected by a convex mirror? The reflected rays appear to come from a point on the principal axis. This point is called the principal focus of the convex mirror. The principal focus is represented by the letter F. The distance between the pole and the principal focus of a spherical mirror is called the focal length. It is represented by the letter F.
Okay. So we have two alphabets. One is a capital F and the other one is a small f. What is F?
F is the
Focus.
focus.
And this is the focal length. Focal length is the distance between the focus and the pole. Clear till now? Did you underline what all we are going to write? Now there is a small activity, a paper, etc. Did you see that? Have you tried doing that? Maybe you are having a broken piece of a concave mirror and you are having a piece of paper there. If you adjust it, what happens? One sharp, bright spot will be formed there. Maybe you would have used a lens for it. Most of you would have probably played around with a lens and not a mirror. But anyway, it's very similar. After some time, the paper will begin to burn. Now my question is, what is happening? Why does it burn? Look at the diagram. You can take the help of the diagram. What are we talking about? We are talking about a concave mirror, and if I'm keeping paper in front of it, okay, and there's sunlight somewhere, it begins to burn. Look at this diagram again. What's happening? What are these rays? Sun rays parallel to the principal axis. So what's happening after reflection? They are meeting at a point. Yeah, they're all converging at a point. So if all the sun rays are converging at a point, what happens there? It is getting heated up. And what have we kept here? Paper. And therefore the paper is getting burnt. Understood? Once again, it's a practical situation. We are making use of our conceptual knowledge in order to explain. Read it. Not the blue part, not the activity part, the paper.
The paper at first begins to burn, producing smoke. Eventually, it may catch fire. It may even catch fire. Why does it burn? The light from the sun is converged at a point as a sharp, bright spot by the mirror. In fact, this spot of light is the image of the sun on the sheet of paper. This point is the focus of the concave mirror. The heat produced due to the concentration of sunlight ignites the paper. The distance of this image from the position of the mirror gives the approximate value of focal length of the mirror.
So what is the question that I could ask you in the question paper? Why does the paper burn? Yes, when you are using a concave mirror. Okay? Understood? So put a Q there. That could be one of the questions which can be asked. Understood, no? So there's no need for you, but you should remember, where are we going to keep the paper? Where should the paper be kept? At the focus. It should be kept at the focus. In front of the mirror, correct. But can we keep the paper somewhere there? No. It should be kept at the focus. Why should we keep it at the focus? So that the light rays are, I'm using a word, converge. Converging is what you should use. So there are certain words that you should use in your answer sheet. What is the word? Converge. So that the sun rays are getting converged at a point. So that it develops heat and then paper is catching fire. Can we find out what is the focal length of this mirror? No? Yes?
It is just
How will I know what is the radius? I don't have. Can I find out? My question is, can I find out by burning the paper? I've kept this concave mirror. I've kept the paper here. It is burning.
so we have found this measure the length and power
Measure the distance between
between
The paper and the mirror.
paper and the mirror. That's it.
That's
Correct? The distance between the paper and the concave mirror itself is the focal length. And using the focal length, can I find out the radius? Double it. Followed. The questions can be as simple. It's just your thinking, how you have to reason out it. Okay? Chal. Make a note of it in your book. Come on, write down. Homework. Terms. Okay. Pole. P. C. P. C. R. Big F. Small f. And principal axis. Take a break for 5 minutes and come in. You can have drink water if you've got some snacks or something. You can have 5 minutes. Okay? If anybody wants to use the washroom, it's here.